Welcome back to the second half of Chapter 6. I actually ended that recording one slide too early, but we talked about rain shadows. We were talking about the four primary causes of lifting, and the last one was orographic. And so we actually we can see this phenomenon with rain shadow deserts. And so all of these deserts occur on the leeward side of mountains. So the Mojave and the Sonoran, the Sahara Desert, the Atacama. All of these deserts are a consequence of orographic lifting and a rain shadow. Next, we're going to talk about clouds. There are a lot of clouds that are in this picture. You do not have to know all about them. There's only a few that I want you to know. And so clouds are large bunches of condensed liquid or sometimes frozen water. They are not a gas, right? We can't see water vapor in the air. We can't see it until it condenses. So clouds are liquid water. There are three main types of clouds, stratus, cumulus, and cirrus, and we'll go through all of these. But the nimbo that you often see on clouds like cumulonimbus clouds, nimbo just means rain, that it is raining or rain is about to occur. So let's go through these different types of clouds. It's also important to know that clouds, what they tell us is how the air is moving. That's basically what forms the shape of the cloud. It lets us know how that air is moving. And so the first type of cloud here, this is a nimbostratus cloud. So nimbo is just meaning that it's going to have some type of rain that's going to happen. But the air is moving horizontally. So anytime the cloud is called something with a stratus, it means that air is moving horizontally. And so here we can see these large set of clouds that are just kind of moving horizontally across the landscape. The next, this is a cumulonimbus. And again, nimbus just means that rain is happening. You can see the rain is coming down over here. But this means the air is moving vertically. Air is rising up, often very, very quickly. But this creates those big, puffy clouds when air is rising. Cirrus clouds is air moving horizontally, just like stratus clouds, but it's very, very high. They look very, very wispy. Fog is formed when moist air is chilled at a low altitude, excuse me. It's not from lifting. So clouds are formed when that air lifts up, but fog occurs when air is chilled at a low altitude near the surface. There are several types. There is radiation, when the cold ground sucks up heat from the air at night. So we get less of this in Southern California, but we do get some of this. But where I'm from, the Northeast, radiation fog that happens at night can be pretty typical. Advection fog is when warm air blows over a colder surface. And so we see here in San Francisco at the Golden Gate Bridge, we're getting advection fog. And evaporation fog is over bodies of water. And so we get California marine layer conditions. We get them a little bit more this time of year, but this is when relatively warm air from the ocean blows towards the coast. And then we get the California current, which is a cold water current that chills that air. And so May gray and June gloom, which we are experiencing now, we get this thermal low pressure that pulls that air towards the land, and we get this layer of clouds that comes in very, very low and close to the surface. And so if you live near the coast in San Diego or in Southern California, you can go quite a while without seeing any type of sunshine during May and June, and you could just go a few miles inland and you won't have that effect anymore. It burns off by the afternoon when the temperatures rise. And then by late June and July, that subtropical high moves north and that wind blows from the land to the sea rather than in reverse. And so that marine layer conditions of May gray and June gloom go away. Here we see advection fog. over San Francisco. San Francisco, if you've ever visited, can be very, very cold in the summer. You get this really cold water, you get warm air that blows over it, and you get this heavy, thick fog that they have actually named. Carl the Fog, he has his own Twitter account. So it's another beautiful summer morning in San Francisco. Don't forget your winter jacket, scarf, and memories of sunlight. I visited San Francisco. The first time I went was in October, and it was beautiful and it was sunny. And the next time I went was in July, and I didn't have a coat, and it was just really, really cold there, especially to somebody who's lived in San Diego for 10 years. It was very, very cold there in the middle of July. And so you could see this like thick rolling fog that comes through the area. Precipitation, right? Because sometimes when we get clouds, you get precipitation. Precipitation results of lots of condensation. So the more condensation equals bigger and heavier droplets or crystals if you're dealing with snow, right? So you get these droplets that form and then they will bunch together. And then the heavier ones are just going to fall by gravity. So those clouds can't hold that moisture up anymore. Those droplets get bigger and bigger, and then they have to fall. This is more common with rapid or sustained uplift. So especially if you get a warm front that is particularly moist interacting with a cold front, and it will shoot up, and you'll get this really rapid condensation, and you're likely to get thunderstorms. Again, more common with humid air, right? Because if that humid air rises up really fast and cools, there's a lot more moisture in there for precipitation to occur. And so we can see here this cumulonimbus cloud, this air has risen really, really fast. It's condensed, and now you're getting rain that's falling down. There are a couple types of precipitation. The first is rain, which we all know, which is just liquid water that's falling. The next is snow. That's when ice crystals are falling down. The next is sleet, which is snow that's melted and then frozen again before hitting the land, and that results in these kind of ice pellets. It's really miserable. It is not a happy precipitation event. And the final one, which is even worse, is glaze, which is a freezing rain. And so water falls as a liquid, but then when it hits the cold surface, it freezes. So we would get these freezing rain events where I grew up, and you would walk outside carefully because everything was covered in ice, but the trees would almost look like they were made out of glass because everything was just covered with this layer of ice. Also not a very nice thing to have to drive around in. And then hail, which you will watch a video of some hail on your own, is when water is frozen and it falls. And hail can come in some pretty large, it can get up to like softball size. Mostly it does not. But again, air has risen really, really, really fast, and it got pushed up really high, so it froze up there and then falls as kind of these bits of ice. And so just to talk about thunderstorms, which is most common with very unstable air when you get this convection in these warmer months. So again, this is what makes hail possible or really heavy rain. You get this really strong updraft, this really humid air that rises really, really fast above to a point where the air is freezing or at the temperature where water freezes, and then it comes down really, really, really fast. You can also get kind of big thunderheads that don't necessarily result in hail. But hail, it's kind of counterintuitive. Hail normally happens when it's warm outside. It doesn't happen when it's cold outside. It's because you get this really warm, humid air interacting with this cold air, and this really warm, humid air rises up, and it's got a ton of moisture. It's pushed up really fast, and then it freezes. And again, you guys will watch a little video on your own of some pretty impressive hail falling. You can also get wind that comes off the water and therefore results in rain. So we get trade winds that are kind of blowing this warm, moist air. So that water can evaporate off of oceans and large lakes. It's one of the reasons why in Hawaii, this is Kauai, you get this trade wind that's coming in. It's bringing all of this warm air over this landmass. So the warmer the water, the more evaporation you're going to get, but the water doesn't necessarily have to be warm. When the wind blows humid air onto the land, it's either uplifted by convection if the land is warmer than the water, or chilled by advection if the land is colder than the water and you're likely to get fog or mist. But if the land is warmer than the water, it's going to get uplifted and you're going to get some type of precipitation. And so often in cold areas, you can get quite a bit of snow. It can also be pushed up by hills and mountains, so that orographic lifting that we were talking about before. And so this is from Syracuse, New York, where you get this lake effect snow. Syracuse, New York is right near the Great Lakes. This is the dome of their athletic complex that actually collapsed under the weight of the snow. But pretty significant snowfall that can happen in upstate New York near Syracuse, because you get that moisture that's just coming off of the Great Lakes and then rising when it gets over land, and then it's already really cold, so it's resulting in snow. So you get this eastern edges of the lake get heavy snow as the winds from the west pick up evaporated moisture from the lakes. So Syracuse, New York, for the vast majority of the winter has some type of snow on it. And again, when we look at this red line there is that ITCZ, you're getting this area of convergence and you're getting lots of rainfall here. In July, when that ITCZ moves a little bit north, because the northern hemisphere is having their summer, the reason why this is so dry here is because it comes across the water over here, it picks up all of this moisture, it drops it, but then there's no more moisture to pick up again. It has to travel over this extremely large landmass with no large bodies of water. And so after it dips back over here, then it picks up more moisture. There's lots of moisture to pick up here, drops more rain off. And so again, if we look at, in January in the United States, so we'll look at Southern California here. In January is when we get most of our rain. We're getting this water that's picking up this moisture, this orographic lifting. The winds are coming from the west, and so you're getting a bunch of rain here. As opposed to in July, you're going to get colder water, less evaporation, so that's when we have our dry time. As opposed to the East Coast, you're going to get a lot of warm water here, winds blowing up this way, and you're going to get lots of fronts and lots of convection and lots of rain happening in the southeast United States. We are going to watch a video that will be the basis of your first exercise for this module, looking at snowpack in the Sierras. We use a lot of snowpack in the Sierras for a big water supply for us. And when we were through the drought, we had very little snowpack in the Sierras. And this past year, tons and tons of snowpack in the Sierras. And so you're going to watch this video about this snowpack. And I want you to think about like why this snowpack might not necessarily be, it's a good thing, but like what problems can happen when you get so much snowpack after going through such a large drought. And again, that snowpack, there is still snow up in the Sierras, even now, most of it's melting now, but we rely on that slow snow melt of the Sierras to provide us water through the summer. And that will be the end of chapter 6. So you move on to your next exercise and then on to the first part of chapter 7.